Hey, welcome to another episode of Automat Live Coding. I spent the whole week fighting with the stuff that we finished with last time. So trying to make the static linking of libxcb work in Automat. It didn't work out, but I did learn some things that will be useful in the future, so it wasn't time entirely lost. And I'm going to actually start by recording a devlog first. Let me first fix some of the string things. Let's start with the title. Okay. The title is going to be Keycode to UTF-8. Send a notification. And I think I will switch off music and record the devlog now. Let's pause this, hide bot, hide music, and start recording. So hey, welcome to another episode of Automat devlog. This one is going to be slightly Linux specific. I'm going to tell you about static and dynamic linking. First, I will show you some arguments for and against dynamic linking, give you some advice, and then show you how my debugging workflow worked for this particular issue that I had here. I will try to end on a positive note. It's not a very optimistic area, but we kind of have to be if we want to make it work. So dynamic linking. Dynamic linking in general is a practice of shipping incomplete applications that can then pull in the relevant missing pieces from the target operating systems. So there are some issues about this thing. One of the issues is that those dynamic libraries, they really depend on the type of the system that you build it on. They are hard to move from one operating system to another. If you build it on one distribution, it usually will not work on another or even a previous version of the same distribution. If the libraries that you are using are lost for some reason, this happens, it becomes very hard to run your library. So you need to take care to properly ship those libraries, or at least think about how you will ship them.
Knight says,
Hey everyone.
Hey, Knight.
Be well and
So you have to think about the distribution. The distribution, you can either embed those dynamic libraries within the installer, or you can download them dynamically from your server, from operating system servers, or you can just ask the user to install those libraries for you somehow. But the distribution is a hassle if you ship the dynamically separately. Stability is an issue. Recently we had a very fast pace of development in AI. So the AI-related libraries, they very quickly iterated on their API. And even though they used a versioning scheme called semantic versioning, it still failed because the authors of those libraries, they quite often simply forgot to properly annotate all of the changes that they made. And the result was just a very painful experience of using, of building anything AI related on any computer. Just PyTorch madness. Then dynamic libraries are also not great for performance because they have to be linked, all of the calls, they have to go through a PLT or GOT, like indirect sections. And even if they don't, they still have to be linked at runtime by the runtime linker. Big software, I mean software that uses tens of libraries, often runs into an issue of daemon dependencies, where different libraries that they use, they have a common shared dependency, which they require at a different version, so doesn't work. When this happens, you have to either downgrade one of the libraries or fix one of the libraries to use the more recent version of the dependency. It's a big issue and it takes a lot of time to fix all of those things. In the end, when a user actually tries to use a dynamically linked program, typically the app just works on one system. And when it doesn't, you get like totally esoteric error messages, like it's not an executable. So an error message, something like that, happens when you don't have the right when you don't have the right runtime linker, like LDSO. And when the libraries are missing, you get a, I would say, nicer error message. But when you look at this error message, try to think not as yourself, not as a programmer, but as a user of an application. Think about a kid or an older person looking at this and seeing an error message saying that error while loading shared libraries, and then a sequence of bizarre characters, cannot open shared object file. This is totally esoteric language. Nobody is going to understand this stuff. So dynamic libraries are not great. They result in pretty bad user experience and pretty fragile software. So what's good about them? There are a couple arguments for those libraries. First, they are more efficient when it comes to memory usage. It may seem like a very weak argument nowadays, but historically, if you go back 30 years or 20 years even, you will see that there was still a debate about how do we want to ship software. And memory consumption, as crazy as it sounds, was the major argument for dynamic libraries. This is one of the reasons why Linux is so memory efficient nowadays. You can have a 1 gigabyte system and it's perfectly fine for a modern system. This is because Linux mostly uses those dynamic libraries. And it was historically the major argument. They can be also good for performance. I said they can be bad for performance because of their linking overhead, but the native libraries can also be built differently. So this is mostly a theoretical argument. Because in practice, I don't think I have ever seen this. So in theory, you could have a faster build of FFmpeg or faster build of like PyTorch on your machine, but in practice, nobody does this. So there is that. There is also a security argument. So if there is a security flaw in one of the dynamic libraries, theoretically and in practice, it can be updated more quickly and pushed to all of the users more quickly, and it results in all of the applications that had this security flaw being patched. It's a really nice thing. It's a really convenient way to patch apps. But it's not a killer argument in a sense that you can still patch those applications by just rebuilding their statically built versions. Performance is also not a really kind of killer argument because, well, we could still use static linking and that would still work. Same for memory consumption. And none of those arguments against dynamically linked libraries are also super strong because, yeah, they are terrible for portability, maintenance, distribution, stability, performance, large software, but they still work in all of those cases. they introduce a lot of pain, but they still work. There are 3 arguments for dynamically libraries, which are those killer arguments. There is just no way around dynamically linked libraries if you want to have those things. So first are plugins. If you have a plugin and you don't have a well-defined protocol of talking with this plugin, for instance, if it was running in a separate process, then it has to run in your own process, then it has to be a dynamically linked library. Then some system interfaces, they are kind of like that, they don't have a well-defined protocols. A few common ones are graphics, especially the 3D graphics, audio, and input handling. When we are writing applications, when we write them today, we want them to still work 10 years from now on future hardware. So the only way to make this happen right now is to rely on dynamic libraries. They expose foundational interfaces for applications that allow them to work long time after they have been compiled. Then there are also some libraries which haven't been designed carefully. So whenever a library contains some global state, this is when you cannot really link it statically anymore, because 2 different components of your system, when they link this library statically, when they want to use different versions of your library, it just results in big issues. Unfortunately, because of the POSIX standard, this is kind of how libc and memory allocation works. This is how threads work, and this is how some interfaces on operating systems like the PAM authentication and DNS name resolution also has some issues related to plugins that can be loaded for DNS name resolution. So dynamically linked libraries may not be the best always, but for some things they are necessary. So my advice in this area, I'm not a huge authority, but my advice still is to only use them when they are necessary. There are places where they have to be used, but otherwise to try to actively work towards switching this into a static version, because the reason for this is that the end goal of this is the better experience for the end user. This is the end goal. This is everything else doesn't matter, because it has to be easy, robust. It cannot crash. So I also mentioned I will give you my debugging workflow that I use when I have to fight against static and dynamic linking issues. So this is something that happened Friday. So we realized that we have to translate keycodes into UTF-8 character sequences. This is a complex problem because different machines do this differently. If you go to some Asian country, they use completely different alphabets. And the translation from Keycode to UTF-8 uses rather complex infrastructure of kind of applications that do this translation. So it's not an easy task to do this properly. So we had to use a library. So we pulled in libxkb common, which can be embedded as a static library, but quickly it turned out that this library doesn't really want to properly talk over our XCB connection to the X11 server. Short while later, we realized that we are using shared libxcb and we have to switch to a statically compiled one. So after properly linking in a shared version of libxcb, so we are doing this using flags like this one. Then we can actually embed libxcb, but in a way that it can still be used. So it actually tricks the linker into using our embedded libxcb and re-exporting. So we are re-exporting libxcb, embedding it statically, but also telling the linker, hey, if any program on this computer needs libxcb, it's built in. You don't have to load anything. So we realized that it was the problem because we had proper logging set up. So that this is the first step of the debugging adventure. Even if later on you switch to a better tools, you always start with printf. Then I switched to GDB, and GDB has those nice options where I could enable debugging of LDSO. If you run LDSO, you will see that it explains some flags that you can introduce. LD-debug. That will allow you to see what's happening in the linker. And this approach, it shown us that even though we are starting with our built-in libxcb, the moment we load Vulkan, it pulls in an external version of libxcb. So we are effectively loading the library twice. So, but still, the LD-debug showed us that even though it loads an external libxcb, all of the symbols are actually resolved to our correct embedded version of libxcb. So in this case, we actually had this library loaded twice. One version loaded from user lib64 and another version loaded inside our binary. It's not listed here. So this command is very useful. This is a GDB command that prints all of the libraries which are loaded. And by stepping through and invoking this, you can see what's kind of happening in the linker. So we knew that the issue was still happening. The next step was to run strace. So strace is a program that can capture system calls from one application into a text file, essentially. So this is what I did. I executed Automat dynamically and statically to produce those strace files. And here I could compare what were the differences between them. And the differences were tiny, and they were exactly around loading those libxcb libraries. See, the dynamic version loads them earlier, and the static version, it still loads them, it just does it a little bit later. Yeah, here. I went through those two files, basically line by line, looking for differences, and nothing was apparent except that we have a connection to the X11 server where we are sending messages. So we have a lot of these write v and receive message. They are just sent back and forth all the time. And strace doesn't really present them in an easily readable way. So the next step was to actually capture those messages. And there is a trick to do this using Wireshark. So we are lucky that we are using X11 because X11 can run over the network. So I created some fake network connection, local network connection to my local X11 server, where the application could talk through the local host interface. Then I executed Wireshark and captured this traffic. And Wireshark has this nice thing called protocol dissectors, and it has one for X11. So if you can capture X11 trace, you can analyze this using Wireshark. So I did capture two traces, one for the dynamic version of our app and one for the static. And then I went line by line looking for differences between them. and I found some. The differences were very subtle. It was about the data that the NVIDIA driver exchanges when it's negotiating kind of connection to the native driver. So it was sending slightly different keys or identifiers. They were like 16-byte hexadecimal semi-random strings. So comparison of those traces actually told us what was the root cause. And the root cause was that the Vulkan driver that NVIDIA ships does some crazy stuff. So one very strong telltale sign of crazy things happening is that we have a lot of proc self maps parsing. This should never be the case. No application should need to parse its own proc self maps most of the time, unless it's doing some crazy hacks. So this is what NVIDIA driver is clearly doing here. Because of that, it seems like it is mismanaging the XCB connection. It is introducing some global state, essentially, to the XCB library. I'm not sure exactly what this global state is, because this library is closed source. It's a proprietary driver blob. But there is some global state there that prevents us from having a nested version of libxcb. So plans for Automat are as follows. So one, there is actually a way to make a static library that still loads dynamic libraries. There is a nice presentation by Andrew Kelly. He is the author of the Zig language, where he shows a trick that can be used to achieve that. And essentially just remove the interpreter annotation from your library, and it suddenly becomes a static library. So we can do this. It can work. And this trick allows us to still use the C library of the target operating system. So we can still use DLOpen and DLSIM for everything. So we can still use dynamic linking for most libraries and static linking wherever we can. So there is hope that we can produce a single binary that will just work across all Linux operating systems. And this is the positive note for the devlog I would like to end with. Okay. So see you in the next devlog episode. Okay. So that was our devlog, and now we will do some of those things that I mentioned in the devlog. So we are not going to do this, not yet, but I will actually store this link in our roadmap because it's going to be useful in the future. Hashtag single binary. Make this small. Oh well, it's slowly becoming crowded in here. Okay, I'm happy I've done this offline because it was like 2 days of constant debugging. And now at least we know what's the issue, so we can just give up on our own hard-coded libxcb and switch to the dynamically linked one. And I want to eventually use DLOpen for libxcb, but I think it's a distraction. We will switch to properly dynamically loaded libxcb later. Right now, I will just put it in the DT needed, so here, like so. So this is what I worked with. This is the Automat compilation line. I had to manually edit. Okay, let me remove some of those things. Export dynamic, whole archive. Actually reorder some of those lines. I think we also don't need those. Okay, let's go to XCB. So our XCB actually we are going to remove large parts of this. So I did some work here to make our XCB build work a little bit better. So the libraries that we actually need are cursor, we need this one. Probably this. Okay, but those we don't need. Let me see if we can... Okay, I'm sorry that the font is so small. It has to be, because it's just a lot of text that I have to see. Okay, it says that, hey, we are missing some symbols. I want to make sure we are putting libxcb there. Doesn't seem we are. Yeah, I don't see libxcb here. Okay, now we have the shared object. Okay, so we also need XCB, SHM, and some others. So maybe I will bring this back. Remove libxcb from here. So we will build our own version of libxcb just for linking, but we will include the shared library. I'm going to skip those. Actually, maybe I need them. Okay, I need the XCB SHM. I am going to link this as a static library, just to avoid dynamic interfaces. Let me also put export dynamic and I just want to have this built and work. And we are not going to embed libxcb. Here we are embedding, linking to the external version of this library. Maybe I can introduce the increase the font size now. Okay, now we need XCB input. So somewhere here, I will steal it. Whenever I change this file, it rebuilds XCB, like all of the X libraries, because I'm potentially changing some important flags. Okay, we need XCB render. Okay, so those will be re-exported. This will make Automat binary way larger, but I think it's worth it. Just to have more predictable behavior. Okay, and now we just need the X test. I'm thinking about using the same section here. Whatever, I will do this. So this type of wrapping causes the linker to include this static library, but then re-export it. Okay. Now when I run it, it works. We are still crashing here. We'll fix this. No problem with that. Okay, we can also take a look at the link, dynamic section of our library. So we can see that libxcb is here now. Okay, the XAU we are actually not linking with this. At least not we don't do this directly. Maybe libxcb is linking with those. Yeah, it is. I guess this is why they are included here. Anyway, those other libraries, we will convert them to static. Most of them can be static without issues. It's libz, std, zstd. Yeah, we'll see. Okay, now I will remove some of the debug comments. I've touched so many things. Okay. I can do this, and now everything in third party should be ignored by Git. But there are some things in third party that we still would like to include, so yeah, this is built in. Actually, let me see on GitHub. Okay, just those two. I changed the recipe for VK Bootstrap, now it's much shorter. Okay, old changes. We should remove XCB, those comments from here. They are causing issues. Interesting, maybe this name is causing issues. Browse. Explicit keyword. So this is some of our debugging code. will bring back the audio. Yeah, this is fine.
Says, hello Jar Jar. This is a reminder that TTS only works in English. Please use English in chat. Thank you.
So for some reason the bot thought that you're talking in Polish. I have no idea. I have some code to detect Polish language on chat. Because I'm Polish, many people try to talk to me in our native language. Okay, I want to see if I can still build this stuff. So let me run release Automat. This libxkb common is strange. It should properly work right now. Okay, the build is still running, meaning that something seems to be working. Oh. Oh, cool. Okay. XCB image, yeah, I think I remember this one. So our extension helper is actually doing some unnecessary things. So we have these C flags from current build type that we are re-exporting. I think we could remove some of them. Yeah, some warning flags. I think those are warning flags. Let me see. W error flags. Another attempt. Because when we compile dependencies, we should be as permissive as we can. So we should not cause unnecessary failures here. Okay, so which program has issues? Okay, this is not working, and we need to reconfigure this. Let's try that. Oops. So this is going to rebuild a lot of libraries now, but it's necessary. Come on. Okay, so it was reconfigured. It would be nice if this printed the flags that it's using, and I would see. They look good. Again, flags look great. Okay, this value is there, but it's not our fault. Okay, so this is bizarre. It's including this flag itself, and then it's failing. See, it's checked for, it's added to the command line by the configure. And then it's failing because obviously it's not returning. Okay, let's search online because this has to be a common issue. Oh yeah, this is our issue, by the way. It adds return after the assert. And then this merged. This is ancient, like CBUtil image. Maybe we are downloading some old version of this library. That could be the case. This one should be fairly fresh. 2022. Yep. check this Git repo. Yeah, it has the issue. Was this removed maybe recently? Committed 13 years ago. Wow. Okay, so this patch was clearly not accepted. Oh, I see. When ndebug is defined. Yep. I see the issue. Okay. And actually, I think I will fix this in a slightly different way. I mean, no, the best way to actually do this is to add the return at the end, not to mess with flags. And I think we have a way to do this. Yeah, we have this patch sources function. Okay, I will just print a log line. Okay, so it says, hey, we are patching this. Okay, first I will go here. We'll create a copy. Oops, undo. I do not want to edit this file. To format. Crap. I can do this in Emacs. Okay, so I would like to do something like that. There is pathlib, but there is no patchlib. It would be so convenient. Maybe we can use the LM to help us here. So let's see. Let's try to use this one. Okay, this is very ad hoc patch function, but I guess it should work. Okay, this is very wrong, very confidently wrong. It will work in this small case, but when we want to make it work for other types of patches, it's going to fail. We open a new. Let's try again. Maybe we could try with a different model. Max. Let's try this one. Should work fine. Nice, error handling. Cool. It seems verbose, but correct. Again, it only works for a single line. It's like, I want general patches to be implemented here. Maybe I need to do this. Okay, I will include a patch like this one. It contains prefix and suffix and file names. I think we need this patch. So I will reject all of this and I will include it using this different syntax. Let's do this again now. Will this work? Let's see. Oh, that was just lazy. I mean, it's not that bad, really. Okay, let's accept it. It's just I will use path as a root source.
TP Chica says,
Hello.
Hey. So I just asked AI to implement a patch kind of in Python, and the way it was implemented was using subprocess. It's a very nice implementation of the patch function. Yeah. Oh god, did it change anything? No. Okay. I mean, yes.
Good thing it was Python, otherwise it would have no clue.
Okay. Line 109. Oh yeah, they love to change indentation style. The language models. Error applying patch. Okay, it didn't change anything. Maybe this. Okay, I should pass P0, I think. Okay, it seems that patching worked. I think I should re-implement this in proper Python. Okay. If this works, I'm going to submit whatever we have. Yeah. Weird things are happening. It works, so I think I will submit this and we can start fixing the weird recompilation. Okay, I cannot run assembly now. I think I disabled some important thing. Yeah, this one. Okay, seems to work. That wasn't a super descriptive message, but enough. I think this apply patch should be part of the patch sources. Union. I wonder, what are unions? Okay, can use this syntax. Okay. Now matching should be easier because I can take this expression, put this here. And remove this noise. lots of unnecessary work has to happen because we edited some files. Okay, I guess it works. Okay, now we got the fixes out of the way. We can go back to the stuff that we have actually been doing before everything went sideways. So we were trying to get the keys out of keycodes. Which apparently is kind of hard. Yeah. If we go to the sources and see how it's implemented, so we have this key map new, this works. Okay, I think this is the one that fails. Actually, to make this faster, I will move this buggy code around a little bit. Okay, so here we are creating the window. Give me a moment. free. I will hardcode free because my keyboard has ID free. Keycode. Need to include this X11. Let's say A, key A. Now we can see very fast failures. We should be able to see, I hope we will see fast failures. Cool. So it says request failed. Actually suspicious about this. Maybe I should step through this with a debugger. I will do that. Okay, our debugger paused. Now we can get in there. This works, this works. This does not. Let's enter this function. This is the one that fails. Reply is null. Why? Maybe I need to initialize it somehow. Let's look at documentation. I am creating context just fine. And do this, we don't care about this. Maybe somebody has seen this. This request should not fail. It's a very simple request. Our server should respond. Two slightly different files. Okay. For this issue to happen, we don't even need this xkb command. Let me try this once again with a debugger. Okay, so maybe the issue is that we are in some kind of linked in XKB, maybe. This one. Maybe we should have used the shared library here. Let's see. You want to see how I'm linking this thing? What? I think it could have been because of the size of the window. Yeah. Now we are linking to the shared library. but the repli is still empty. Can store an error here. Be right back. Can I somehow format this error? Okay, one thing I could try is I could remove some of those. Let's remove all of them except one. And see if this will help. Nope. Or maybe the first one was causing issues. So let's try with the everything except the last. Still. Major code is 135, minor is 8, so it's none of those. Oh, this is a nice library. Still unclear to me how to get the name of the error out of this. There are like 3 different functions to do it. Okay, let's grab these XCB errors. I think we have it. Okay, this is different. This is XCB util errors. Or maybe it's the right one. I'm not entirely sure if this will work correctly, but let's try. Let's include this file. It's actually coming from my system include. Okay. And we also have header. Okay, now we should be able to see what this error is all about. Access. Yeah, pretty much. Why am I getting access error? Yeah, this is another access error, the same as we are getting. Maybe that's the issue. We have to call this xkb use extension. Yeah. I was basically forgetting to set up this extension. It sounds like something that should be part of the documentation, I think. This is just incredible. It's in this quick guide. This quick guide actually doesn't mention this. Okay, I don't think I need to do this.
PIET says,
How do?
Hey. Actually, when I'm looking at this, okay, we are still getting access errors. Okay. I need to do something else to initialize this extension.
I am 13 and I am learning assembly today. Please help me. I already learned C and OpenGL, but assembly feels wrong.
Hey, it's not that battery. We actually have some built-in assembly in Automat, so if I kind of remove the return so that you can start it. Assembly is kind of complex because it's poorly documented. The materials about instructions are scattered. There are those PDFs from Intel which describe each instruction, but they are hard to find. You kind of need to know that they exist before doing anything with them. Yeah, we are trying to make our own environment for writing assembly. Yeah, hopefully in a couple of weeks this issue will be fixed. My advice, for assembly is to actually get a book. Books for old languages and assemblies in old language are very good. They will contain all of the stuff that you could possibly need for it. And I don't mean the Intel references. There are plenty of assembly programming, like paper books, not PDFs. Check this out. It was actually explained here in the header, but not... Whoa. This is just terrible. Let's go back here. So we can either use this one, I don't know why would we pass those flags here, but apparently there is a helper function somewhere. Okay, we can only pass no flags. This will be the actual version. I am removing this stuff from here and reintroducing it here. Next one are flags. Not passing any flags. and then a couple null pointers. Okay, this should make it work. Yeah, there is a reply. It works. God, it took some time. So now the nice thing is we can finally translate keycodes to Unicode. So much work. Something so simple. So when we start, when we connect, this is where I'm going to put this. Look at that. Suddenly it works. We don't even need this XKB header. Okay, required size equals 1. Servicing memory. Setting text to 0A. Doesn't seem to be 0A. Check something. I'm curious, what if I type some weird letter like... I don't think we will see sequences of more than 32 characters. Okay, this part is working good, it seems. It seems we are getting proper localized key now. Now we just need to implement key down in our instruction. Actually, when I look at those extension usage issues, I wonder whether the issues that I had with NVIDIA driver were also because I didn't call some extension use. Like they explain here. I just want to see, are there any other extensions that rely on this? Hey, apparently not, only XKB. Okay. Okay, so here I think the instructions, they are configured to use integers. Okay, something worked here. I could set it to 10. And look at that, it's even reflected in the immediate value here. I can do 1000. Okay, so I think after calling this buffer visit, so we are returning true to indicate that, hey, we changed the buffer contents. Yeah, this is where we should read the buffer contents again. This is wrong.
UTF-18 says.
I am 36, and I have no idea what in looking at XP.
Can fire it up if you've seen like Incredible Machine, the game. I think there's other similar games. I think it's good. It's a good analogy to what we are building. Except this one was just a game for the sake of, like getting a ball from one point to the other. We are actually trying to make this play games.
Thanks.
The DI is, kind of simple. Okay, after spending 4 days debugging the X keyboard library, the fact that they have this quick guide that doesn't mention that you have to initialize this extension, otherwise it's going to fail in some weird way. So the documentation looks nice, it's very well written, but it omits a key detail. Oh. there is a Boolean operator. Text refresh here and I guess here. Do more changes, more subtle changes, like caret positions. Okay, I'm doing it like that because sometimes the widgets do not allow, for example, non-digit characters, so moving caret would produce an error. Seems now we can finally type in those fields. Interesting things happen when I try to type too much here, because we are trying to set this to 1000 and we are only filling the final byte. I actually wonder where this happens. I think here. I think I could handle this by checking span size. think if the value is 0, I think we should handle this slightly differently. Can I type minus? I can. It actually does something. Yeah, it properly negates the number. It just prints it always in positive. We just need a better... we just need to implement the button here. There is going to be a button right over here for switching the mode. Change this to 8. This isn't necessary, actually. Okay. It's actually nice that this kind of started working by itself. So the instruction preview also seems to work now. we are using actually negatives here. So this is locked to anyway, and this just shows the proper sign of the value. So I think we accidentally made it also work in the timer. So now we should be able to type numbers here, because they should use the same okay, what's that? Okay, it's not perfect, but whatever. We can type stuff there, at least. It doesn't have effect, but we can type there. Okay, I think I'm actually wondering, do I make a break or end the stream now? I think we achieved what we wanted to achieve today, so now we can properly read keys and we can type on top of instructions now. So I think during the next stream we'll probably implement other input methods, so this button here that will be used to switch modes of this input widget between text, hex, positive and negative numbers. Yeah, and I think this should be good for the next stream. It works so smoothly.
Knight says,
Have a nice day.
Yeah, you too. See you around.